And we're back with another classic problem. That's problem 49, grouping anagrams. It's a medium problem, but I think it has, it's really an easy one, especially for those who have been doing LeetCode for quite a while. Now, let's just read through the problem description to understand what is needed here. So we're given an array of strings and we should group them such that anagrams should be grouped together. And as a reminder, an anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all of the original letters exactly once. So for example, eat and tea, they're anagrams of each other because if you rearrange the letters in eat, you can arrive at the word tea, right? Same for ate. Ate, tea, and eat, they should probably, they should be grouped together. Here's the bed in this example doesn't have another word that it would be grouped together with, but the word net and tan, they're also anagrams of each other. So we are returning the group of anagrams from our array of input strings. And let's look at the constraints. This is always a must. A lot of people keep forgetting that. So, okay, we see that the length of the strings is limited. The length of, wait a second. Okay, we get an array of strings. So the length of the array is limited, but also the length of every string inside the array is limited. And, oh, this is good to know, every string inside the array consists of only lowercase English letters, which will make things a lot easier for us. So, well, if we want to group things together, I think a natural idea should be to use a hash map and things that are grouped together should have the same key. And we don't know how we're going to determine what the key is yet, but we know that if we had a key that identifies items by how similar they are, we could put into a hash map all of the words under the same key that are anagrams of each other. So that's kind of the basic idea. And we're going to use a little convenience function or object here from Python. And we're going to use the default dictionary. The benefit of the default dictionary is that when you let me just close groups. When you try to access a key, so for example, and that key doesn't have an entry yet in the dictionary, you don't get an error. If this was just a regular Python dictionary, you would immediately get an error at this when you're trying to access element n because it doesn't exist. So default dict makes it a little easier for us, and it would actually create a list when we try to access element n that doesn't exist yet, and we can immediately append something to that list. So that's why we're using this. And I think in LeetCode you don't even have to import it. It's going to be available right away. But depending on your programming environment, you might have to import it. So anyways, so this is what we're going to do. And we're going, in the end, we need to return the groups, right? But we're going to have the groups stored as the values of our dictionary. So we already know that for grouping in groups values. So in a dictionary, you have keys and your values. And this is how we extract all of the groups. So we could just return this. All right, cool. So now, well, what do we do? Well, we have to compute a key for every single word in our string, right? So for word in strings, and we have to perform, calculate the key somehow. And then we're going to append that string. Oh, I wish I could type. We're going to append that word under that key to our dictionary. And that's pretty much it. So now the challenge in this problem is really to determine what is the key. And I'm going to have a little helper function here. Compute key. And it takes in a string. And it should return to us maybe also a string. It needs to be something that is a valid key for a dictionary. Not everything is a valid key. So an array, for example, wouldn't be a valid key. So key equals compute key of the word. And I'm just going to leave it like this. So now how do we do this? Well, we can exploit the fact that we only have lowercase English letters. So from a different problem, I think it was, I don't remember the number, but there's a problem where you have to determine if two strings are an anagram of each other. And one of the ways to do that is you could just compute all the characters and just sort them. So this would definitely give us, well, if we have two different words that are an anagram of the other, for example, eat and tea, the result would be, if we sorted those characters, A, E, T, yeah, like this. And it would be the same for the word eat and for the word tea and for the word ate. So we would always get back the same as key, right, if we do that. Now, this sorted thing gives us an array. So what we'd have to do is we have to convert it back into a string. So we could say key is that and return the key. So let's take this for a little test run to see if that works as intended. I haven't tried it myself. So yeah. So on the examples that we have, it works just fine. Can even deal with some edge cases like the empty string. Nice. And but the problem is now, because sorting is n log n, right? We could optimize this. And another trick that we learned in the anagram problem was that we could just build the histogram of each string. And we could use the histogram as the key. So a more efficient way would be to compute that as the key. And in this case, what we'll do is we simply iterate over all of the characters. And then we compute the index of the character, and that would be, well, we convert it to an ASCII value. We subtract the ASCII value of lowercase a because we're dealing with lowercase English letters. And that'll give us an index that is 0 base from 0 to 25. So now we can just use that in our to update our histogram and update that. Now, since this is an array, it can function as a histogram. So what we could also do now is we could just convert it back to a string. So we'll join all the elements in the histogram or count in histogram, but we have to convert it to a string. Otherwise, join will complain that it can't join to integers. So if we run this now, it should also work as intended. Now, because it only consists of lowercase English letters, sorting and this approach, they're both constant time and constant space. But if you were dealing with an alphabet of arbitrary length, then this would be the better approach, because this is now O of n time, where n is the length of the string, and O of m space, where m is the number of different letters in that string. So yeah, that's kind of just what I wanted to show you. So the trick here is really to, compute a key that groups things together. And then all you need to do is use a little hash map. And that's all.